everyone, and thanks for taking time out of your busy day to join us. My name is Jacob Evelyn with Applied Sim Technologies, Inc., and our company has 24 years experience helping companies in the industrial machinery industry designing better. I'll be your host today, and again, thank you for joining us. It's an exciting yet challenging time to be in the food processing equipment industry. The industrial food processing equipment industry is estimated to be $42 billion, going to $53 billion by the year 2016. This market is being driven by changes in food consumption, consumer awareness, and government regulation. These trends can have a great effects on your business. Industrial food processing equipment, commonly referred to as IFPE, which I will mention quite often in this presentation, face dramatic pressure to improve the speed and efficiency of their product design and engineering so they can reduce and deliver on time with increased profit margins. As we'll see, some of the best in the IFPE industry are leveraging technology to thrive in this competitive business environment. During this 30-minute webinar entitled Lean, Clean, Machine Design, we'll show you how. Here's a quick look at the agenda for today. We'll start by briefly looking at the industry trends, their effects, and their unique challenges. We'll identify the key capabilities within the food equipment companies. And we'll also provide several success stories and how companies are using engineering software tools to improve their business. Okay, let's begin. We'll take a look at some of the current trends today. Changes in the consumer habits and growing population are demanding for more processed food, which is driving higher demand for IFPE equipment. Environmental concerns are placing a greater focus on packaging, being green, lowering energy usage. This increased awareness is driving food companies to pass on these requirements to their suppliers. These trends require food equipment companies to design custom machines faster, provide a better way to visualize these products for sales and marketing. All right, have you ever taken a minute to think about what trends are impacting your customers? They're facing pressures to lower labor costs, reduce operating costs, all while providing a safe work environment. IFPE companies must improve operating costs to stay competitive and improve working environments to reduce their risks. Okay, now that we've covered some of the industry trends, we will review how these trends are impacting IFPE companies. As you probably are aware, equipment manufacturers are facing cost pressures too. Just as the food producers are facing pressures of rising and unstable costs of raw materials, so are the equipment manufacturers. Rising costs for purchased materials, sheet metals, raw material, energy costs are also on the rise. This impacts equipment manufacturers to have an inaccurate cost estimates and a threat to overall profits. Finally, looking at the last piece, government regulations in the IFPE industry are influencing equipment design more than ever. Also rises in consumer awareness and their attitudes towards food safety regulations. IFPE companies need to apply strong control within the design and manufacturing process to ensure that equipment they deliver meets the industry standards of cleanliness, hygiene, and safety. No longer is it just good enough to produce average equipment. The industry is demanding lean, clean, machine design, so companies are looking for ways to design better. If you're facing pressures like these, you're not alone. To help you see how companies are maximizing their opportunities, let's take a look at an IFPE industry leader, AMF Bakeries out of Canada. AMF Bakery Systems is the world's leading manufacturer of high-speed bakery equipment. AMF designs and manufactures a complete line of automated baking equipment from mixers, makeup equipment to slicers, baggers, post-packaging solutions, as well as washing machines for the bottling industry. The picture you see here is one of AMF's combination proofing and continuous oven systems. This equipment is designed and manufactured to have a high yield of volume, up to 120,000 soft buns per hour. Let's take a look at what AMF was challenged with. What AMF was challenged with, like a majority of the IFPE companies, is much of the equipment AMF designs and builds is customized with certain time constraints. Specifically, AMF faced the following challenges. Customizations leading to increased engineering times and added costs, promised delivery dates that can lead to costly overtime, unstable material and energy costs that can affect project bidding, equipment needs to easily clean, for industry hygiene standards for safe food production. So for AMF, to maintain their global leadership, they needed to find a way to turn their challenges into opportunities. AMF took a deep look at their design process and analyzed their strengths and weaknesses. We'll return to AMF later, but now let's step back and look at the entire design build process for companies in the IFP industry. All right, we're going to shift gears. So to be competitive, companies like AMF must adopt effective and efficient engineered-to-order product development processes. In our work with these companies in this segment, we've identified 12 key capabilities that drive success. These 12 capabilities shown here are everything from marketing, selling the product, engineering them to order, planning, manufacturing, commissioning, and servicing them. As you look at these, how could your company improve? Mechanical CAD is just one of the supporting engineer software tools that can be used to improve your capabilities to design better. This is just the case for AMF. Every company is different. All of the 12 capabilities are important to AMF, and we're going to dive a bit deeper into just 3 of them. We'll demonstrate these and how they are important and how we can overcome these challenges in each area. The 3 capabilities that we're going to take a look at today are reducing customized content, visualization of new products, speed of mechanical design. So let's keep moving. The first challenge we'll look at is reducing customized content. Sales and engineering staff need to optimize the product specification to fulfill the customer's needs while minimizing the need for customized product development. It's a balancing act that can greatly impact margin. How many times have you been in a situation where you'd like to reuse an existing equipment design? With traditional 3D modeling, reusing the data could cause the user many problems in the regeneration and unplanned errors. It might just be easier to start over or hit the undo button as far back as you can. And how can Siemens technology help with this? Wouldn't it be nice to reuse your existing data regardless of who authored it and regardless of what system it was designed in? IFPE companies can reduce risks by fulfilling more orders with standard product configurations. Siemens provides the technology to manage the product configuration and the options throughout the sales cycle. Staff can now select preferred configurations based on experience and standards. Here at Applied Sim Technologies, Inc., we represent Siemens PLM software, which has a product called Solid Edge. And now I would like to introduce Jake Genexella. He's an application engineer with Applied Sim Technologies, and he's going to dive into Solid Edge a little bit deeper. So take it away, Jake.
Thank you, Jacob. So Solid Edge with synchronous technology allows the user to make precise changes to imported geometry by adding 3D driving dimensions to any geometry. Another unique capability within Solid Edge is the ability to make direct edits to imported geometry by pushing, pulling, and rotating geometry with the capability we call steering wheel. This amazing capability will automatically recognize key features, allowing powerful parametric type modifications effortlessly. There's also patented technology called live rules that find and apply original design intent. What does all this mean? Lower overall design costs by being able to work with imported data. Let's take a look at Solid Edge in action. Efficient sourcing of off-the-shelf supplier items such as motors and clamps can be a challenge, especially with an increasing push towards standardization for reduced costs. Also, as these are not in-house manufactured items, why spend the time and effort modeling them up yourself? Solid Edge has some great tools here. To better focus on the design area of concern, we can easily change the visible parts in which we are viewing by applying a display configuration. Our first task is to create the gears needed to drive the wheel paddles. We can quickly review some requirement notes saved in our binder for those gear sprockets. The main benefit of the binder is that it allows you to link pertinent information to a specific assembly. Rather than spending time modeling them, we'll use engineering reference, which offers a wide variety of ready-to-build engineered components, such as gears, pulleys, shafts, and much more from a parameter-driven interface. Just enter the pertinent information for the component you need. An engineering reference will analyze the calculated results and provide feedback as to whether the components are strong enough. If everything checks out, a simple click on the Create button and the components get created and placed into the assembly. You only need to provide component names. Don't forget there's a standard parts library with machinery library extension, perfect for hardware or fasteners like nuts, bolts, and washers. Notice after creation, the gears are placed into the assembly where you can add specific relationships to position them. To maintain their current position with each other, we'll first add a rigid set relationship. Another benefit of using solid edge when placing components in an assembly is the assemble command. This allows you to place different types of relationships from a single command. Notice here you can place multiple relationships between two different parts without ever leaving the command. We also want these gears to drive the paddles, so we'll quickly add some more rigid set relationships between each of the components to achieve this. Another benefit of using engineering reference is that it automatically adds the gear relationships needed between the two gears. Notice how the gears will stay in sync during rotational movement. And we can also animate the results by adding a rotational motor to one of the gears, as well as set the rotational direction and speed. Once set, you may want to use Simulate Motor to test the results. The simulation provides you visual feedback that the gears are performing as needed. Also notice the gears driving the paddles that are connected to them. If a kinematic analysis of this motion is required, for example, to help find power requirements, this too is something that's possible. The second area that needs to be completed is on the back belt, where we have a sketch driving the length of the belt. Typically, belts are a purchased item and come in standard sizes. We can use the sketch in combination with GoalSeek, a tool used to optimize our in-house design for standardization. Here we need to ensure that the tensioner can cope with the standard belt length, or else the frame will have to be modified. Notice we have the tensioner in place, but as we move it, you can see we need to lock into position. An added benefit is that we can use the same sketch that drives the belt length to also locate an axial line and lock the tensioner into the correct position. Now the next step to getting the correct belt length is to calculate area properties within the belt sketch. For this we can use the area command, which gathers area property information and places it in the variable table for us to use in our calculation. We can easily locate the perimeter, which is our current belt length, but let's rename it to make it easier to locate later. Also notice that we have a variable called tensioner adjustment. This is the variable that we'll use to drive the length of the sketch and achieve the proper belt length. The variable table built into Solid Edge enables you to set formulas between variables as well as variables of other components. Here we can extract variable information to help us quickly achieve the belt length we're looking for. Now that everything's set up, we're ready to use GoalSeek to figure out the proper length of a purchased belt for our conveyor. Notice the streamlined menu where we can first select the goal variable, then the variable to drive the actual belt length, and finally the target value we want to achieve. Simply provide GoalSeek with the appropriate values and watch Solid Edge go to work. Now the final step in finishing our conveyor system is to add a couple of clamps to our frame design. Typically these parts would be supplier purchased or catalog parts, so we can quickly source them from the Solid Edge part community. Part community offers access to billions of Solid Edge files, can just search by supplier, description, shape, number, size, and more. To take it a step further, Part Community can also find a purchasable part by matching a file you upload. For example, as gears we created from the engineering reference. Finally, to make sure you found the correct part, the 3D viewer can be used before downloading to Solid Edge. Powerful tools making your job simple and fast. I already did this in advance, so we'll simply go get the parts from the parts library and drop them into our assembly. I know I already mentioned the assemble command, but it's important to point out that anytime you place components into assembly, the assemble command automatically puts you in position to begin placement. For this clamp, we first add a mate relationship and then 2 alignment relationships to ensure it's in the correct position. Anytime you place a component more than once, Solid Edge offers a tool called Capture Fit. This tool will take the relationship used to originally place the component, learn them, and then apply them on the next placement. Let's see how this works with our clamp. I'm simply going to paste the same clamp into our assembly, and notice the from face is already highlighted. This makes component placement a snap and leaves no questions about how it should be placed. So with the ever-challenging push towards standardization to reduce costs, you saw here that not only does Solid Edge offer various libraries, local and in the cloud, to provide pre-modeled standard and catalog parts, it also has great tools to accelerate your design towards utilizing them. Thank you, and now I'll pass things back over to Jacob.
Great stuff there. Very compelling. What I want to chat about now is build-order equipment companies and what they want to improve and the way they communicate a proposed machine before it's built. It's difficult to sell a physical machine when one does not exist, so a virtual prototype would be a huge help. So to be competitive, sales staff needs to communicate their offer in a distinct, innovative way with features and the use of advanced technology. Failure to convey visualization can lead to a costly design changes and even worse problems like a loss of sale. And how we can help is with Siemens technology. We can provide fast, easy to create 3D photorealistic rendering and animations. Solid Edge has photorealistic renderings that produce virtual product pictures. Your sales staff can show varieties at marketing events that can help you stand out from the competition. This helps sales and marketing staff provide rich 3D product information, which helps improve sales. They can present AVI movies with machine motion, exploded views, or interact with the model on a smartphone, iPad, Android device. By having this virtual image, machinery manufacturers can test new products and create interest in the new products and variants before they are made. Companies leveraging this technology become recognized as distinct and gain a competitive advantage in the marketplace. For many of our customers, creation of the 3D model is great for generating new business and creating the engineering model. However, the byproduct of these models is 2D drawings, and that can be used to manufacture the physical equipment in the end. This is a common challenge for many companies because they end up using 2 different CAD systems from 3D to 2D. But with Solid Edge, this is not a problem because we have integrated 3D to 2D in the same system, which is not the case for all their mainstream CAD systems. We recognize designers and engineers are under pressure to work faster and more efficiently, and with Solid Edge, they have a complete integrated system to help them design better. To overcome these challenges, Solid Edge provides a complete integrated software solution to make the design process faster and more efficient. Engineers can produce 3D models, accurate 2D drawings, and can reduce design time and eliminate design errors. Solid Edge helps engineers speed up design, execute faster revisions, and better reuse of what they've already done. For IFPE machinery manufacturers, this means delivering sooner, invoicing earlier, lowering business risks, and more opportunity for growth. Let's take a look at how Solid Edge can help your company gain a competitive advantage from accelerated design. Yes, I know almost every 3D CAD company can make this claim, but what makes Solid Edge unique? What makes Solid Edge unique is a disruptive technology called synchronous technology. Synchronous technology is a patent technology available only to Siemens PLM software. This innovation has dramatically changed the game in product development because no pre-planning is required. The user can design in a history-free environment and accelerate the design process. The user does this by focusing on the design intent versus the design tool, and not wasting time by trying to predict the future changes like traditional history-based systems. Additionally, Solid Edge gives the user the freedom to redesign on the fly, respond to customers' demands and changes. We can do this because of another unique capability, where the system interrogates the 3D model and automatically captures the design intent. This gives the designer a more productive user experience. Accelerated design. What could this do for your company? You could get products faster to market, up to 25%. Another thing we do really well with Solid Edge is faster revisions. Solid Edge with synchronous technology allows designers and engineers to edit models and drawings in a constraint-free environment. Solid Edge does this automatically with a tool called Live Tools. Jake mentioned that earlier. It's kind of like having an experienced co-pilot with you as you drive. So the models don't need to be regenerated, and what this means for the designer and engineer is blazing fast performance. What used to take minutes, or what used to take hours, only takes minutes now. Now we're going to take a look back at some of the success stories. We're going to return to AMF Bakeries. The results that they were able to achieve were amazing. The design phase was reduced by 50%. They greatly reduced the amount of rework by 15 to 20%. Rework on complex sheet metal assembly was almost eliminated. Less overtime, more profit. AMF is just one of the great examples how Solid Edge helps IFPE companies design better. And another case study we have for is Lutenhager Frey out of Switzerland. They're a leader in the electric bakery equipment, and they were challenged with trying to standardize models for improved reuse. Their business goal was ultimately shortened, so design cycles, excuse me, they ultimately shortened design cycle times, allowing them to shorten their time to market. The company's 2D system was causing a variety of concerns. Its effectiveness was being challenged, especially considering market advancements in 3D. Management soon began examining the leading mid-range systems, particularly in terms of the company's unique needs. Considering this, it only made sense that the new system be fully 2D compatible. So their solution, they went with Solid Edge. And once again, they had compelling results. After adopting Solid Edge, their designers reported huge time savings. What used to take 3 weeks only took a day. It led to significantly fewer errors and part interferences. Solid Edge enabled design modifications to be made significantly faster and easier. And its incredible sheet metal capabilities easily handle Lutenhager's intensive sheet metal forming applications. And our last success story is Woodstone Corporation in North America. It's a leading manufacturer of stone hearth cooking equipment. The cornerstone of the company's product line is a wood-fired restaurant oven that has been adopted by many of the country's hottest chefs, including Wolfgang Puck. For many engineers at Woodstone, they created 2D drawings of oven components using AutoCAD. They sent these drawings to suppliers who fabricated parts, which when they brought back to Woodstone and they were assembled, there were several drawbacks to this 2D approach. Firstly, it was difficult to envision how the parts fit together. Errors such as fastener holes not lining up and multiple pieces of sheet metal might not be found until the assembly process, which caused delays. So what Woodstone was able to do with Solid Edge is their design productivity increased by 50%. A faster design cycle helped Woodstone win new custom orders, and significant time and cost savings through reduced assembly glitches, all helping their bottom line. AMF Canada, Lutenhager Frey, and Woodstone are real companies with real results. As we've seen today, we have large proven benefits. Design times were cut by 50%. Capacity for new product development increased by 30%. Significantly fewer errors and part interferences found in manufacturing. Earlier we talked about Solid Edge throughout this session, and we've not formally introduced it yet. Let's wrap up this session with a brief overview of Solid Edge. Solid Edge is a complete 3D design and engineering solution. Solid Edge for 3D parts and assemblies, using synchronous technology to accelerate design, speed revisions, and improve the reuse of previous designs. Solid Edge simulation for digital validation of critical components, reduces the need to create physical prototypes, lowering material costs, testing costs, and improves reliability. Solid edge manufacturing for accurate machining, fabrication, assembly processes, and improves overall manufacturing efficiency. Solid edge design management improves the overall efficiency of equipment design and ensures the accurate product data, specifications, and requirements documents that are available to everyone. And Solid Edge is a growing ecosystem. Solid Edge apps extend the capabilities of Solid Edge to provide a complete ecosystem for product development and manufacturing that meets the needs for today's IFPE companies. There's a vast array of apps within the Solid Edge ecosystem, include plug-in solution providers like KeyShot for photorealistic rendering, Cortana 3D for product authoring, NXCam for manufacturing, and many more. So now that you've heard what Solid Edge can do, let's take the next step by trying out for 45-day free online trial. You can try a full version of Solid Edge free with no obligation, or you can get a test drive right here at Applied Sim Technologies. We'll walk you through the Solid Edge framework, the interface together, and we'll send you home with your own copy. And now I'd like to open it up to any questions. Okay, now that we don't have any questions coming up, I'd like to thank you guys for joining us on the behalf of the entire team here at Applied Sim Technologies. I know we know your time is valuable, so if you have any additional questions and you would like to know more about Solid Edge, please contact either me or Jake directly. And if you'd like to get Solid Edge for a free trial, you can email us at our emails below. Thank you once again, and we hope to hear from you soon.